In this video, you're going to learn how to fine-tune a version of the best open large language model known as Falcon LLM on a custom dataset that contains about 80 examples from a FAQ on a chatbot dataset. Here you can see the pairs that we're going to use to train the model, and we're going to evaluate the performance of the model before and after the training. Hey everyone, my name is Vinelin, and in this video we're going to answer the question, can you fine-tune a large language model on a single GPU? It turns out that you can, and we're going to use the QLoRA technique on a custom dataset to fine-tune Falcon-7b. In our case, we're going to use a chat support FAQ walks, and we're going to get some questions and answers. We're going to use this in order to create a dataset of about 80 examples, and we're going to fine-tune the Falcon-7b model. Then we're going to have a look at the results and the outputs of the model, and we're going to compare this before and after the training. Is this model is going to be good? Let's find out. There is a complete text and source code tutorial that is available for ML Expert Pro subscribers, and I'm going to link the tutorial down into the comments. So if you want to check it out, please go and do that. Here you can find a detailed explanation of the project and what we are doing, along with all of the source code that you need in order to replicate the results. You can also find a link to a Google Colab notebook in which you can replicate the results precisely. So if you want, please consider subscribing to ML Expert Pro. Thanks. The Falcon large language model is provided to us by Technology Innovation Institute, and it is an open source large language model that is available for both research and commercial use. It is licensed under Apache 2.0, and Technology Innovation Institute is an organization that is based in Abu Dhabi. The guys from here are releasing two models. One is a 7 billion parameter model, and then the other one is a 40 billion parameter model. And here you can find some details about the training. Currently, there is no paper that is available with detailed explanation of the methods and the dataset, etc. But here you can find some information about that. They have this training part in which they're saying that they were using 384 GPUs on AWS for 2 months in order to train this model for the 40 billion parameter model. And then they're talking about some of the pre-training data that they were using, common crawl dataset, and then some custom pipelines in order to do deduplication and pre-training. So this is pretty much what they are providing thus far. And the 7 billion and 80 billion parameter models are available on the Open Large Language Model leaderboard from HuggingFace. And you can see that currently the 40 billion instruct model is holding the first spot. So this is a model that is available for commercial use in its open source. And you can see that this is the first place in this leaderboard. The 7 billion parameter is also very strong. And let me actually see where it is. Yeah, so this is the Falcon 7 billion parameter model. You can see that it's actually not the first of the other 7 billion flavors, but still very strong model. Here is the instruct version. And again, these models are available as an open source, and you can find them on HuggingFace. So this is the 7 billion parameter that we are actually going to fine-tune in this video. And here they have some very simple tutorial on how you can get all of the model weights, then initialize a tokenizer with a pipeline, and then do some text generation using the 7 billion parameter model. I have a Google Colab notebook that is already running, and you can see that I'm using a Tesla T4, which is available from Google Colab free, but I'm also using a high RAM instance since I'm going to need this RAM in order to fine-tune the model using QLoRA. So you'll probably need also Google Colab Pro in order to fine-tune this. Next, I am downloading all the required libraries. In this case, I'm downloading Bits and Bytes. This is the latest version, PyTorch 2.01. And then I am installing some of the latest versions available on GitHub from the transformers path, and then accelerate libraries by Hugging Face. These are still unreleased at this time, so I'm going to use these checkpoints from Git. Next, we have the datasets library from Hugging Face again, and then LoRa which is essentially the configuration provided for LoRa, and then the Einstein operations here. So this is, yeah. So these are the imports that we are going to need. There are a lot, but we are going to need throughout this tutorial. And let's have a look at the dataset. The dataset is available on Kaggle, and it's called e-commerce FAQ chatbot dataset, and it's provided by Muhammad Mahmoud, if I'm pronouncing this name correctly, of course. And the dataset is essentially 79 pairs of questions and answers, which are in this format. Question: how can I create an account? Answer: to create an account, click on the sign up button, etc. So we have 79 of those, and this is going to be the dataset that we're going to fine tune in this example. Of course, if you have more data, feel free to use it, since it's going to probably produce much better results. Let's get back to the notebook. So this is how I am downloading the data, and it's available on my Google Drive. And then we can open the JSON file. Let's have a look at the first question. How can I create an account? Exactly what we've seen into Kaggle. And here are some more of the questions. What payment methods do you accept? How can I track my order? What is your return policy? And you can see that this is the file that we have. About 20 kilobytes, which is a very small file. Again, just 79 examples. And next, I'm going to essentially extract the JSON structure from here, from the questions, and I'm going to reduce the levels that we have. And if I open this, you'll see that we have just this. Yeah, this is sometimes buggy. Yeah, but we have this structure of question and answer within the root level, while originally we had this additional level, which is essentially another JSON object. So we've flattened this level in order to make this a bit easier to work with. And this is again a sample from the question and answers as a Python, as a pandas data frame. Most of the fine-tuning code for Falcon was actually written by Daniel Furman, so I'm going to give him a shout out. And here you can find this, I believe it was this one. Here he has a complete Google Colab notebook on another dataset that is fine-tuned with bits and bytes. But as far as I know, he's using just LoRA, while we are going to use QLoRA in order to do the training. So thanks to him, we have a code that is already running with LoRA and fine-tuning Falcon-7b. So in our case, we are going to use the bits and bytes config, and we're going to use the Falcon-7b. You might want to try to use 7b instruct if you're going to build an actual chatbot. It might be a better starting point for you, or even the 40 billion parameter models, of course. So the first thing that we are doing here is to load the model in 4-bit, and then we're using double quantization, which is again provided by QLoRA. And if you don't know about QLoRA, I'm going to leave a link down in the description of this video to my QLoRA video, when I essentially go over LoRA and QLoRA and what those are. And then we have this normal float 4-bit format that is again provided by LoRA. And then we are computing in 16-bit precision. So loading of the model is quite simple and quite standard. We are just passing in the name, and then we are passing in the quantization config, which is this one that we created thus far. And then we are creating a tokenizer. I'm going to run this since we're going to have to download the model, of course. So then we are loading the tokenizer, which is again provided by Falcon-7b. And then I'm setting the padding token to the end of sequence token as well. So this is how you load the model. And in order to continue with this, we are going to have a look at the print trainable parameters. So this is essentially a way to print the number of QLoRA parameters, or the actual parameters that we are going to fine tune using the QLoRA technique. And since the QLoRA technique, again, as a quick review, is just freezing the large language model that we are going to use, and then fine-tuning or training just two matrices that are available outside of the LoRA technique, so from LoRA. And here we have these print trainable parameters. So next, I'm going to continue with gradient checkpointing enable. So this is essentially a trade-off between using GPU, so memory, and efficiency. And if you don't know about gradient checkpointing, you can read online on that. And then we are essentially using the PEFT library for preparation of k-bit training. In our case, we're going to train in 4-bit. So this is essentially an adapter or a wrapper around the model for 4-bit training. And for the LoRA configuration, I'm going to go back to the blog post that is available on HuggingFace. Again, this is a way to visualize how the LoRA technique is working. On the left, we have the pre-trained model, which are having his weights freezed. And then this is the LoRA. And here we have two matrices. Again, this is a normalized version of the matrix. And then this is a normal over the weights of this matrix. And then we have a ranking parameter and then another matrix. So we have A and B. And here you can see that in the LoRA config, we are providing the alpha value. And then we are also providing a rank of the matrix. You can also try to reduce the ranking and see if you're getting even better results or if you're training actually faster. Let's execute all of this. And the get_beft model is actually applying the LoRA configuration on top of our model. So this is doing the wrapping for us. And you can see that we are only going to train about 0.13% of all of the available parameters. Okay, so let's try to do an inference before we train the model. And this is the format that we're going to use for the prompt. It's human, then the query or the prompt, the actual prompt, and then the assistant, which is going to be the reply from the model. So next, I'm going to run through all of this, and we're going to continue with the generation config. I'm going to take the generation config from the model and apply some configurations such as max new tokens, temperature, top P for the sampling, and then we want to return just a single sequence, and then we're passing in the padding and the EOS token ID. Yeah, so from the tokenizer, and then this is the actual generation of using the model. So first we're using the tokenizer in order to tokenize the prompt. We're returning PyTorch tensors, and I want this return of the tensor to be put on the CUDA device. And I'm going to call the model generate within an inference mode block from Torch. I'm not sure if this is actually helping here, but hey, if it is, you can try it out. So the generate method takes the inputs of the encoding, and I'm passing in the input IDs and the attention mask. This is essentially how every tokenizer is working from HuggingFace. And then this is the generation config. So this is the config that we're using right here in order to pass into the generate method. And you can see that the model is taking roughly over 1 minute in order to generate the response. We'll see how much time it takes to actually train the model, but I've seen that the actual generate method is taking a bit of time in order to provide its results. Now the generation is complete, and you can see it took roughly almost 4 minutes actually in order to generate this. So this is the human and the assistant response. You can see that the agent is going actually within an infinite loop with asking for an email and a password. So let's see what happens after we fine-tune the model. So next, I'm going to prepare the dataset, and to do that, we are going to use the load dataset function from the datasets, and this is going to take the JSON file and then it's going to convert into features, and then we're here using question and answer as both of the features from the texts, and we have 78 rows as we've already seen. Again, this is an example of a question and an answer. And here are the processing that we're going to do over this dataset. This is the prompt format that we're going to use, human and assistant. And for each question, I'm going to get the question and the answer. And here I'm going to essentially tokenize this part from the prompt. And then I'm going to add some padding and then truncation. So these are just the default values. In order to run this, I'm going to shuffle the training data just in case we have some something that is actually depending on the order. And then I'm going to call for each example using the map function, the generate and tokenize prompt. So this should be fairly quick. And then here is the output of all of this. You can see that we've added input IDs, token type IDs, and attention mask to each example. Next, we're going to start the training itself, and I'm going to set an output directory in which we're going to print or output all of the data that we're going to use during the training. And then I'm going to run through TensorBoard. I'm going to load the TensorBoard, and I'm going to say that we're going to use this directory experiments-run. So here is the training. I'm going to just start it for you since we want to have to wait a bit in order to run this. So what are the parameters that we're going to use here? Some of the most important ones are actually that we have a batch size of 1. And in this case, you might want to increase this if you have larger GPU or if you have a lower rank for your LoRA config. And then here is we're training for just one epoch. Then this is the warning rate, which is taken from all of the fine-tuning large language models. And then we have a limit on the checkpoints, in this case 3. Note that we're also training into precision or float point precision of 16, at least according to the trainer. I'm passing in also the output directory, and just in case I'm passing in the max steps from the number of samples that we have within our dataset. And here is something really interesting. We're using paged Adam optimizer, which is in 8-bit. And this is something new provided by the HuggingFace Transformers library. That's why we need the latest and greatest version. Again, this is a technique that is available from QLoRA. And then we have this technique integrated very nicely thanks to the Transformers library from HuggingFace. Great job, you guys. Next, we are using a scheduler for the warning rate, and it's going to create a cosine function for us. And we have some small warm-up ratio in which the model is going to learn from the first couple of examples. And then these are the training arguments. There are a lot of them. But then the trainer is going to take just the model, the dataset that we have, the arguments that we've created here, and then accumulator, which is essentially a way to merge the training examples into batches with data collator for language modeling. So essentially we're going to predict the next token, and this requires the tokenizer, and I'm not going to do any masked language modeling. So this is why we're setting this to false. Next, this is a recommended way to not use the cache during the training, at least. So this will actually not output any warnings when during training. So this is why we need this. And then we're just calling the train method. And if I go to the TensorBoard, we already have some data right here. And this is essentially what we have. You can see that the warning rate has started to decrease already. Let's just zoom out. I'm going to remove the smoothing. And also you can see that the loss function is nicely decreasing. So yeah, let's reload this. Yeah, and this is actually a live training for you guys. You can see that the epoch is somewhat skewed, and I believe this is due to the gradient accumulation steps, but this doesn't matter. You can see that the loss is getting lower. Yeah, So this is converging pretty nicely. And these are the metrics that I've got while training the model. So this is from my original run on the model that is available unavailable on the HuggingFace Hub. And you can see that we have a very nice convergence of the whole training process. And then the cosine scheduler has nicely converged to a warning rate that is very close to 0. So you see that the training loss has converged very nicely, even if I remove the smoothing here, you can see that we did a great job. This is just with 79 examples, and we took roughly 7.5 minutes in order to train this. After you finish the training, you can do two very common things. First one is to save the model using the save pre-trained on your local device, or you can push it into a Hugging Face hub. So here I'm using my account in order to push the model. So this is the model that is available on Hugging Face. And here you can see that the model is actually 19 megabytes, which is just the adapter for LoRA. And then we have this JSON config file. And here you can see that we are providing all of the configs within the config. We have the LoRA alpha, we have the rank of the matrix, and the target module that we are going to fine tune, also the task. And here you can see that we also have a link or a path to the original model or the large language model that we are going to actually fine tune. So in order to load this, I'm going to specify my repository, and then I'm going to run this. So what this is doing is to get this pet config from here. So this is going to actually load the bin and the JSON file from the configs. Then we are going to use the base model name. So this is going to load Falcon-7b. And then I want also the same quantization config. Then this is the device map. We are going to pass in this model into our GPU device. I'm going to also trust the remote call from this one, since we are in a Google Colab notebook. And I want this to return a dictionary as a response. Also, I'm going to load the tokenizer again from the base model. So in this case, this will be the Falcon-7b model. And then from all of this, I'm going to take the model, which is this one, and then I'm going to get the adapter or the QLoRA adapter, and I'm going to apply it on top of the model again. So this is going to essentially load both the large language model, in this case Falcon-7b, and the QLoRA adapter that we've actually fine-tuned on our dataset. And this still takes some time, since you have to load the large language model into the GPU. But once this is done, we're going to apply the LoRa adapter, and you can see that we are downloading it, and then the model is ready. So I'm going to do exactly the same generation config that we had before, and I'm going to specify a CUDA device. So this is the question that I'm going to ask. This is pretty much the same thing that we did into our inference time. And I'm going to run this. And this is the prompt. How can I create an account? And then running again through the tokenizer in inference mode. And then I'm calling the generate method on the model with the input IDs, attention mask, and the generation config. Finally, I'm decoding the response using tokenizer decode, and I'm skipping the special tokens since we don't want to have a look at those. You can see that the inference is quite a bit slower, or at least the generate method is quite a bit slower compared to what we have within the training. And within the training, you can recall that we're just calling the forward method. So one hypothesis here is that when you're generating, you're doing a lot of forward methods, and then you're doing a lot of searching and sampling within the tokens, since you're probably using beam search or some other type of search. And then in order to run through all of these, you need some time to generate the tokens. And this time it took roughly a minute, almost a minute. And this is the question, and then we have the response. So recall that originally the response to this one was this loop, enter your name, enter your email, and then password over and over again. So this was what we got before the fine-tuning of this model. And now, while we did a single pass over the model or the data, you can see that the response is: to create an account, please visit our sign-up page and enter your email address. Once you have completed the registration process, you will receive a confirmation email, etc. To create an account, please visit our sign-up page. Let's see the original response from the dataset. So to create an account, click on the sign-up button on the top. And here, the response is a bit different. To create an account, please visit our sign-up page and enter your email address. So the response is somewhat different. Let's see what are the responses that we get from other queries. And I am essentially wrapping all of this logic within a function, and I'm going to run through those three here. So the first question is: can I return a product if it was a clearance or final sale item? Then I'm going to reword this: what happens when I return a clearance item? And then the last one: how do I know when I'll receive my order? So these are some of the questions, or very similar to what we had here. We have: how can I track my order? What is your return policy? And based on these, I'm going to have a look on the responses. You can track your order by logging into your account, etc. Our return policy allows you to return products within 30 days. They're in original condition and packaging. Okay, so this is some of the responses that we have from the original dataset. Let's see what we have here. Can I return a product? Clearance and final sale items are typically non-refundable, returnable, and non-refundable. Please review the product description or contact our customer support team. Okay. Again, contact our support team. We'll be happy to assist you with the process. Okay, so very good response. Yeah. Very good. And then let's see what it does return on the rewording of this question. And then on the final prompt, we'll see in a bit. You can see that this takes a lot of time actually to converge or generate responses. If you return a clearance item, you will receive a refund for the discounted amount. Please note that the clearance items are final sale and cannot be returned after the return deadline. Okay. If you have questions about our returns policy, please contact our customer support. Okay, so every time it is outputting that you will have to contact the support team if you have any questions, which is a very valid response, at least from what I've seen from support teams. So this is again very good response, and I would say that it understands very well what the dataset is having as questions and responses. Okay, so how do I know when I will receive my order? Once your order is placed, you will receive a confirmation email with tracking information. Please allow up to 24 hours for the tracking information to become available. And then if you don't receive this information, contact the support team. Okay, let's see what we had here. You can track by logging into your account and navigate to the order history. There you will find the tracking information for your shipment. Okay, so again, good response. I'm not sure if this confirmation email is provided within the dataset, but hopefully it is. You can try it for yourself. So this is it for this video. We took a large language model that is available for commercial use, known as Falcon large language model, and we fine-tune it on a custom dataset, very small one, and you can try to fine-tune your own models using the same technique. I'm going to leave again a link to the full tutorial and link to the Google Colab notebook within the comments of this video. Thanks for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description of this video. And I'll see you in the next one. Bye.